Hi, my name is Sverre, and I'm a Director of Engineering at SingleStore. Today we're going to be talking about operational BI. The title of my talk is Operational BI, Executing ML Models at Speed and Scale. So you might have guessed, we're going to be talking about ML, AI, and ultimately defining why you need operational BI and operational analytics at your company. So we have an agenda. The 3 items on our agenda is first addressing dashboards. I argue that dashboards need help. It's no longer sufficient to just have dashboards that serve to help you dig through your data. You actually need dashboards that actually teach you about your data. And they're going to do that by taking advantage of operational analytics and using ML and AI to learn from that data automatically and surface insights. And once we discuss some dashboards, we're going to be talking about operational analytics and really understanding what it is. Fundamentally, operational analytics is about connecting the dots, and I'm going to teach you what that means. And finally, we're going to be doing a demo of operational ML using SingleStore and Amazon SageMaker. So first, let's discuss dashboards. Dashboards need help. Every company has a data explosion. What does that mean? It means that we're generating more data per day than we have ever done in history. Dashboards are no longer enough by themselves because it's not sufficient to dig through the data piecemeal. You can't just use a dashboard to just look through data. You need to have dashboards actually teach you and surface insights. Fundamentally, we want to be able to apply ML and AI to our data and surface the results of looking of those models, those AI and ML models, directly to our users via dashboards. So we need to sort of level up the content in our dashboards to be more productive and more useful. So fundamentally, if you get nothing else out of this presentation, I think the takeaway here is dashboards should be about driving decisions, not digging through data. But how do we do that? We need operational analytics. And in order to understand operational analytics, we need to understand where our data is, what kinds of data it is, and sort of how does that data relate to each other. The first kind of data that you have at your company, funny enough, is called operational data. This is the data that you need to operate your company. Traditionally, it might be stored in something like Postgres, MySQL, MongoDB, and operational data tends to be transactional in nature. Think about things like your product database, right? It contains all of the products of your company, and it might contain useful information like properties of those products, when the product was last sold, who's bought those products, those various shopping carts and ledgers that are involved. That data is extremely useful, and your company doesn't exist without it. So fundamentally, operational data is sort of the data you need to operate your company. Then you have historical data. The best way to think about historical data is the context for your operational data. In order to understand what's happened and what might happen in the future, we need to have historical data and operational data. Historical data tends to exist in something like Amazon Redshift, Snowflake, or Google BigQuery. Usually it's sort of operated in like a batch method. Either we're inserting data in batches or running queries over the data that tend to look at large amounts of data at a time. So you might run like a large analytical query that streams terabytes of data from Amazon Redshift, for example. The third kind of data is streaming data. I like to think about streaming data as the nervous system of a company. It tends to be full of events. It tends to be full of sort of ephemeral events or little pieces of data, which are usually immutable in nature and by themselves don't offer that much value. They only offer value when they're tied together with operational and historic data. Usually we'll see streaming data show up in things like Amazon Apache Kafka, Amazon Kinesis, or RabbitMQ. So with all those different types of data, what exactly is operational analytics? The goal of operational analytics is to connect the dots. The idea of it is to take those 3 different types of data, operational, historical, and streaming data, and bring it together and allow you to learn from it all in one picture, all at the same time. And it's super critical that we do this in order to be able to expose the necessary data to ML and AI models to be able to get really intelligent insights out of those models and be able to take action today. We have to have those models have access to historical data at the same time they have access to the latest records in our Kafka queue. So a common thing I've heard, and I've actually seen this more often than I would like, is people putting everything in Postgres or some other sort of single box relational operational database. Now, nothing against Postgres. I love Postgres. Postgres is a spectacular database. They've done a really great job, but it's not designed to be an operational analytical database. It's designed to be a somewhat constrained relational database for handling your operational data, but not all of your historical data, not all of your streaming data. It's super good at what it does, but it doesn't scale to the needs of operational analytics. So with that in mind, what are the properties of an operational analytical database that can help us identify maybe a solution that would work for this purpose? I've written down a couple of traits here. The first trait is horizontal scalability. Fundamentally, operational analytics needs to be able to handle historical data just as well as it handles operational data. And with that in mind, you need to be able to scale your operational analytical database out to hundreds or potentially thousands of machines. So horizontal scalability is key to be able to handle those very distinct workloads in the same system. The second requirement is separation of compute and storage. What does this mean? Separation of compute and storage is about having your computation, the distributed system that actually does operations on your data, separated from the fundamental storage of that data. Why is this super important? Well, imagine that you have a petabyte of data sitting in S3. You have a bunch of Parquet files that you are just sitting around and they're mostly idle. Like you pretty much don't care about 90% of them at any one point. You want to run a query over just 1% of that data. You don't want to have to download all one petabyte of data and keep it online in a database if you only want to access 1%. So separation of compute and storage allows us to have a much smaller compute cluster operate on a relatively larger set of data than it would otherwise be able to operate on. This is super critical in modern operational analytics because it allows your ML and AI models to have access to whatever data that they need without pre-deciding which data to sort of hydrate into an online database. The third trait of modern operational analytics is high performance over real-time and historic data. It's really important that our databases have all the data structures and indexes in place to be able to be just as efficient at handling large-scale key value transactions as that database is efficient at handling large-scale analytics. These two query patterns have very different computational profiles, and it's important to have a database that can handle both of them equally well. The next thing that's necessary is one integration for BI tools. What do I mean by that? What I mean by that is if you take any BI tool, your favorite one in your company, you should be able to use it with a modern operational analytical database. It's pretty straightforward. If you want to use Power BI or Tableau, it shouldn't matter, right? They should both work. And the final requirement, and maybe one of the key requirements, is acceleration of data science. It means that you should be able to do training and ML using data and actually run models using data in your operational analytical database, just as well as any other system.
Now that we've established a good understanding of operational analytics, and we understand what it is to be a modern operational analytical database, let's look at a demo we've put together of loading a model trained in Amazon SageMaker Studio directly into SingleStore, which is an operational analytical database. To get started, on my screen you can see the SingleStore customer portal. The SingleStore customer portal is our entry into SingleStore Managed Service, or our cloud service. SingleStore Managed Service allows you to run a SingleStore database in the cloud and access it through both the command line as well as from other systems such as SageMaker Studio. In this case, I'm using SageMaker Studio in my browser here, and I also have SingleStore Studio, which is basically our version of a basic IDE for accessing a SingleStore cluster. So here's Amazon SageMaker Studio. SageMaker Studio is basically an integrated development environment that allows you to easily work with SageMaker to train, deploy, and use models at scale. Conveniently, SageMaker Studio works really well with SingleStore. So basically how this demo works is I start off by initializing a lot of system settings, which basically just sets up the SageMaker environment. I'm not going to go into too many details, but most of this comes from SageMaker tutorials, and we'll be able to release all of this code open source on github.com/SingleStore at a later point. So first, we go ahead and upload the data. So I have this training and validation data set. This data set is a customer churn data set. So it basically tries to understand why customers may or may not churn from a particular service. Once we uploaded the data set, we can basically configure our hyperparameters. In this case, I'm using XGBoost, which is a machine learning, sort of an auto machine learning framework for doing really quick decision trees, basically. In this case, we're just using a basic estimator in SageMaker. We put in the training and validation, and we call fit. A couple of minutes later, we have a model. What we're doing here is we're using some code that SingleStore has actually provided, which will actually take an XGBoost model and convert it into a series of user-defined functions, which can then be loaded directly into the database. Once we have these UDFs, we go ahead and initialize our environment, and we load the UDFs into the database. And just to show you that it all works, once we've run this, we can actually, from SageMaker Studio, we can run predictions that are actually running inside the database engine. As you can see here, we're running our model as a function inside the database engine. And if we jump back over to SingleStore Studio, we can see that we can do the exact same thing. Our model shows up here as a function. It takes in all of our features, and it returns a prediction of whether or not that user or that session would result in a churn. If we run this here in SingleStore Studio, we can see that in this case, I've just selected users with high numbers of international calls, and I've compared that to whether or not we're going to see a churn. And so maybe we might want to do something like group by one, and maybe we sort of take the average of the prediction. So now here's the average prediction for each number, for a certain number of international calls. So for users with high numbers of calls, the predicted percentage of churn is relatively, can be a little spiky, but I would say overall pretty low. And for users with lower number of international calls, the prediction of churn actually increases. This might mean that the user just isn't as engaged with the service. By putting the model directly in the database, we have the ability of being able to do ML inferencing and surfacing those results directly through SQL into the same dashboards that we might use for all of our other data analytics.
In conclusion, today we talked about dashboards should be driving decisions, not digging through data. It's really important that with the rise in data that we have today, we make sure that our dashboards are about surfacing insights from AI and ML models. But in order to do that, we need operational analytics. To deploy operational analytics at your company, you need something that we might call an operational analytical database. This presentation discussed what it means to be an operational analytical database, what operational analytics is, and how we might use something like SingleStore to run real-time ML and AI models on our data that maybe we produced using Amazon SageMaker. That's been the talk today. I hope you learned a lot. Thank you so much. My name is Sverre, and have a great day.